I like to teach 4 key approaches to doing simultaneous equations, and here they are. The first approach is the plus or minus approach. So you have 2 equations, and in this case I would add them together, just like a big sum. So that's 3x plus 3y minus 3y, there's nothing left, equals 7 minus 4 makes 3, so that means that x equals 1, and then we can work out, we can deduce that y equals 7 minus 3 divided by 3 equals 4/3. There we go. Let's do the next one. Do you know what? I'm nervous now that I could have got that wrong. 7 minus... yeah, that's fine. Let's do the next one. So that's the plus or minus approach. The second approach is you can divide. So you can just literally take equation 1 and equation 2, and you can do 1 divided by 2. So that means that 25 divided by 1, let's not write an equal sign there, is ka cubed divided by ka. Why can we do this? Because we know the left hand side is circled slightly differently. The left hand side is the same as the right hand side in both cases, and so if you do left divided by left and right divided by right, the 2 fractions must be the same. So 25 equals a squared, so a equals 5 or a equals minus 5, and then we could work out what k is as well. So k equals 1/5 or k equals minus 1/5, which I would have worked out just by subbing it into one of the other equations. I actually subbed it into the second equation that looked easiest. Let's do the next approach. You can also do substitution. This is my personal favourite approach. I think generally, I'm always a bit nervous to say this, but I've barely met an equation I can't solve using simultaneous equations, using substitution. But sometimes it's very, very messy. Anyway, so I can just put this, because I know that's equal to y, into there. So that'd be 2x squared plus x plus 2 squared equals 3. Because this is quite a high level video, I'm just going to kind of skip some steps here. Plus 4x, then plus 4, then minus 3 makes plus 1. So then I'm just going to factorise. 3 is a prime number, so I don't really have any choice. It's going to have to be 3 and 1. This is assuming it factorises, but I'm just going to assume it factorises for the moment. And in fact, I can see that it does factorise. That works. So again, saving time, not doing this properly. X equals minus 1 or x equals minus 1/3. Let's do one more example of the fourth approach. Oh, so the fourth approach is you should make y equal to y. I like to remember this one because sometimes I find it saves a lot of time. I can rearrange this to say y equals 11 minus 2x, and I can rearrange this one to say y equals x minus 1. What I've done is I've switched the y and the 1 over, or you could think about it as I've moved the y to the right and the 1 to the left, and then I've switched the equation over left to right. Anyway, so then I can just say y equals y, which means that 11 minus 2x equals x minus 1. So I could just sling that over the other side, sling that over there, which means I've got 12 equals 3x, so x equals 4, and then I could just work that out from, say, this equation here, and this equation here tells me that y must be equal to 3. And if I wanted, I could sub it back in this as well, just to double check, and in fact, yeah, it does work. There you go, that's the 4, what I would describe as the 4 main approaches to solving simultaneous equations.